project fueled fire. At first, I had trouble deciding what I wanted to do for my project because in elementary school we had a lot less freedom and we couldn't do as many projects because of safety reasons. Once I got to middle school, I realized that I had a lot more freedom and we could do many more projects. I then chose my project to be about chemical fires because they are a real problem to our world and are very interesting. I decided to pick three chemicals after doing my research: kerosene, peppermint oil, and castor oil. I tried to keep my research on credible websites like Britannica because not only does it give you the definition, it also gives you uses of the item so you have a better understanding. I also looked up safety websites to try to keep my project as safe as it can be. My question is, if three chemicals are chosen, then which chemical would have the highest temperature and which chemical's color would differentiate the most? I thought this to be an interesting question and to use it. My materials were three glass containers, a fireproof apron, a smoke vent, goggles, a mask, fire-resistant gloves, a thermometer gun, kerosene, peppermint oil, and castor oil. My hypothesis was if I light three different chemicals on fire, then kerosene would burn the hottest and have the biggest color change because some types of kerosene fuel jets, so it must be hot and durable. My process was pouring the three different chemicals into three different glass containers. At first, I tried to just light the chemicals with just a match to see if it would light the surface area, but it did not because it would douse out the fire of the match before we could actually light it. So what I ended up doing was put a rope in and lit the end of the rope and waited for it to go slowly down to the surface of the chemical and light it. After seeing kerosene and taking my results, I realized that kerosene was a lot less flammable than I thought it was. So the highest temperature for kerosene got around to 3 or 400 degrees Fahrenheit, and the color barely changed at all. For peppermint oil, whenever it finally got to the surface and lit, it was really cool to watch because as it lit up, the fire shot up and it looked like it was shooting fireballs straight up into the air that evaporated very quickly. The highest temperature for peppermint oil was around 700 degrees Fahrenheit. For castor oil, it was very disappointing because the surface area didn't even light. So I ended up taking the temperature of the where we lit the rope. The conclusion. My conclusion is that my hypothesis was wrong because peppermint oil is a lot more flammable than I thought it was. So it was able to burn for the longest, making the highest temperature and the most color change. How this affects the real world is that if I was to do this again and do more research, I could do this on many more chemicals, so that way we could have a better understanding of chemical fires and how to identify them, so that way we can deal with them more quickly so they cause less damage in the world. Thank you.